So 1-3, evaluating limits analytically. Yesterday we did tables or graphs, or we should have. And today we're going to do work analytically. Okay, I want to review some skills with you though. You need to remember that if I have the sum of cubes, they factor to the cube root of the first plus this cube root of the second. And then you square the first, multiply the two together, opposite sign, and square the last. Remember doing that pattern? Well, we did a lot. So again, is you take the cube root of the first. So the cube root of A cubed is A. It's addition. Cube root of B cubed is B. So A and B are your first and second now. Square the first, opposite sign, multiply the two together, square the last. Now, if you look at the difference of cubes, it's the same pattern. It's cube root of A minus cube root of B. So A minus B, A squared plus AB plus B squared. Always, always, always positive on that B squared. Okay, so the example I have is 27A that's cubed minus 8. Is 27A cubed a perfect cube?
Yes.
It's 3A, right? Is 8 a perfect cube?
Wait, yes.
2. Okay, so what is the cube root of 27A cubed?
3A minus 2.
3A minus 2. Okay, now we square 3A and get 9A squared. Opposite sign, so not minus, but plus. Multiply 3A times 2. 6A. And then square negative 2, so it is a positive 4. This chunk back here, the trinomial, will never be a real solution. So the only solution to this is A equals 2/3. Okay, next, the conjugate to 3x plus 1 is 3x minus 1. The conjugate to the square root of x plus 2 is the square root of x minus 2. So we need to remember that because these are conjugate pairs. So when they multiply together, this is 9x squared minus 1. Yes? That middle term goes away. And this would be the square root of x squared minus 4. So it'd be x minus 4. Okay. So the important part of conjugates is to get rid of that middle term that you don't want. So if I had 3 minus I, what's the conjugate of it?
3 squared.
3 plus I?
Oh, wait.
So I'd have 9 minus I squared. Well, what's I squared?
1.
Negative 1? So it'd be negative, negative, so it'd be plus. So the answer would be 10. So again, the whole point of a conjugate is to get rid of things you don't want. Okay, so we need to remember that. Okay, so here's some basic limit rules. Let B and C be real numbers, so they're constants, okay? Let n be a positive integer. So the limit of B as x approaches C is B. So the limit of 6 as x approaches 7 is 6 because there's no variable in it. You'll see an example in a minute. The limit of x as x approaches C is just C. the limit of x to the n as x approaches c is c to the n. So I'm just replacing the x with the what? With the c? So the limit of x squared as x approaches 2 would be 2 squared, which would be 4. That would be rule 3, wouldn't it?
Yeah.
Okay. So the limit of 3 as x approaches 2 would just be 3. There's no x to plug into, is there? The limit of x as x approaches negative 4 is
4 or negative 4.
negative 4. So when you're writing the rules, you're like, yeah, this lady is crazy. And then you're like, oh.
So would C be rule 1?
Say that again.
Would C be rule 1?
Rule 2.
Rule 2. B would be rule 1.
Oh, okay.
Because
Yeah, it's the same.
questions? After you did an example, it made complete sense, right?
Yeah.
You're just plugging in. And this, there's nothing to plug into, is there? So it's just what it is. This would be y equals 3. It would be a line, a horizontal line at 3. So it would be 3 no matter what, correct? Okay, so here are some more rules. Just let me explain and then I'll give you a chance to write, okay? And I'll pause the video. So B and C are real numbers, N is an integer again, F and G are functions. Got it? Okay, so the limit of f of x as x approaches c is L. That limit is L. Okay, so the limit of g of x is k. So if we have a scalar, see it as b of f of x, you would just multiply b times the limit. So if this was 4 and b was 6, it'd be 6 times 4. Okay, the next one is the difference. If I have the limit of f of x minus g of x or plus as x approaches c, you find their limits individually and what do? Add or subtract them. Pretty basic, kind of makes sense, doesn't it? Okay, if you multiply them, then you just do what with their limits? Multiply them. Quotient would be division. If you're dividing them, you just divide their limits. And the limit of k can't be 0 because you can't divide by 0. They are going to have that every single time, right? Okay, power. If you have f of x to the n, you're going to take the limit to the
Power.
nth power. So this makes sense. Okay, I'm going to pause it and give you guys time to... Okay, so find the limit. So do you see basically what we're going to be doing if I use the rules from the last one?
You just plug it.
I could say the limit of x squared plus the limit of 3, couldn't I? See that? Because this would be f of x and this would be...
Well, why can't you just put in the 2 for the x in there?
Because you don't have a rule like that.
But it's going to turn out.
So that's your answer?
No, we got to plug in. Because on the first slide, what does it say to do with that 2? Plug it in, yes? So it'd be 4 times 2 squared plus, and what's the limit of 3?
3.
No,
3?
3. So then 2 squared's 4. 4 times 4 is
16.
plus 3 is 19. Now, Riley goes, why can't I just plug in the 2? Can you? So 4 times 2 squared plus 3. 16 plus 3 is 19.
Okay, we have the limit of b equals b. And
Yes.
the limit of x equals c. How the
Yes.
heck am I supposed to know if it's b
Okay,
or
b
x?
equals, c is the constant. C is 2.
Okay,
Did you not write as x approaches
No,
c?
I have it. Okay.
Okay.
Well,
So
how
b,
do I know if it's b or x?
because x is a variable, b is a 3.
Where are you looking at for B or X?
At the very
The
first slide,
rules. The rules.
the basic rules.
Miss Meg, explain it again.
Okay. This b is a constant.
Okay.
This is a variable. So you're plugging in the c into the variable.
Well, isn't
What's
it
the
most of the time it's
difference?
going to tell us if it's X or B?
Oh, never mind. Never mind. It just clicked.
I
Okay.
was like, Cadence, what's the difference between a constant and a variable? Okay, thank you. You thought you were starting, like my life was meaningless for the last 4 years. Okay, so
Hey, did you play your video? You recorded?
yes, I am recording. Okay, here's another rule straight from the book, and these are all in 1.3 if for some reason you want to look at it more. If p is a polynomial function and c is a real number, then we can just plug c in. Okay, just what Riley just told us on the last slide.
Okay.
Okay,
That was right.
so if it's a, yes, but I hadn't told you that yet.
Wait, what's a polynomial function? That's like the first time.
I'm literally
Like
this.
this, if it's a function in its own.
Oh.
Okay, so Riley's like, well, couldn't we just plug it in? Well, yes, we could, but I hadn't told you that. So find the limit of x squared plus x over 2 divided by x plus 1 as x approaches 1. So I am going to be a little picky here. Your work does not ever go next to it because your work is not the answer here. Your work is underneath. So I'm going to plug in what for all the x's?
1.
1. So I got 1 plus 1 plus 2. And 1 plus 1. So I've got what over what?
4 over 2.
4 over 2. So my answer is
2.
2. The work is not your answer at all. Okay, some more rules. Just take them as what they are. Let n be a positive integer. The following limit is valid for c if n is if n is odd, and is valid for c is greater if it's even. Okay, so what I'm saying is this is a radical. Yes? Yes? This is a root. What do we know about an even root?
It's even.
Can you take an even root of a negative number?
No.
No. So what this says is if this is odd, it works every time. So if n is odd, you just plug it in. Again, did we just plug it in before?
Yeah.
Yes. But if n is odd and c is negative, it works. If n is even and c is negative, does this work? No, because it's in negative going into an even root, correct?
No.
That's all that says. Would that have made sense? Like, should you have known that? Probably. Okay, so the composite function, so that's where you're putting a function into a function, yes?
Yes.
So you find the limit of g first, and then put that limit into f. Is that any different than what you've done on composite functions before? No.
Really?
So you find the limit in g and plug your answer into the function of f. You don't. Okay?
Yep.
Okay, so f of g, where f of x is the square root of x, and g of x is x squared plus 4. So I want the limit of f of g of x as x approaches 0. Oh, it's going to change because I touched it. Right here. So I need to find the limit of what first?
G.
G. So I need to find the limit as x approaches 0 of x squared plus 4, which would be what?
Hold on. A 4.
How, Jane?
0.
Well, you plug in the
plus
0.
0 plus 4. That's all I just wanted. How? 4
Then you plug the 4 into.
into here. So f of 4. So the square root of 4 is
2.
2.
You know, I only know because I just looked at the clock.
Okay, next one. We'll do one more. So the limit of f of g of x as x approaches 0. What are we going to do first?
X and the G.
What was that? The limit of
0.
g. Yes?
Yeah.
Okay, what's the cube root of 0?
0.
0. So then I need to find f of what now?
0.
0, which would be 0 minus 10, which would be...
Not all numbers.
Well, there's some other stuff in it, but we'll finish notes tomorrow.